What is Zeroth Law of Thermodynamics? The Zeroth Law of Thermodynamics states that if two bodies are each in thermal equilibrium with some third body, then they are also in equilibrium with each other. Zeroth Law of Thermodynamics can be stated also as systems that are in thermal equilibrium exist at the same temperature. This says in essence that the three bodies are all the same temperature. The credit for formulating Zeroth Law of Thermodynamics was Sir Ralph Howard Fuller. Fuller was born at Croydon, Essex, England on January 17, 1889 and died on July 28, 1944. Fuller was a British physicist and astronomer. He was initially educated at home, going on to attend Evans Preparatory School at Horace Hill and Winchester College. He won a scholarship to Trinity College, Cambridge, and studied mathematics, becoming a wrangler in Part 2 of the Mathematics Tripos. The concept of Zeroth Law of Thermodynamics is to compare the temperatures of multiple objects. These concepts of temperature and of thermal equilibrium are fundamental to thermodynamics and were clearly stated in the 19th century. The name Zeroth Law was invented by Ralph H. Fuller in the 1930s, long after the first, second, and third law were widely recognized. Why it is called the Zeroth Law of Thermodynamics? There were three laws of thermodynamics originally established and named. Then the scientists realized that one more law is required to complete the set. However, the Zeroth Law is the formal definition of temperature, and it is considered as a more fundamental law when compared to the other three laws. The three laws were already well known by their corresponding numbers. Renumbering the name would create confusion. Calling this is the fourth law and putting it in the last of the list was also being confusing because it is the most fundamental law. Since the law is the fundamental one, the scientist Ralph H. Fuller came with an alternative and numbered the new law as a lower number 0, and the law is called the Zeroth Law. Here are some examples of Zeroth Law of Thermodynamics. If the system E is equal to system C and system B equal to system C, therefore system E is also equal to system B. For example, if you put a cup of coffee and cold water in a room temperature without interaction of heat and leave it until a few hours, the temperature of coffee and cold water will be in thermal equilibrium because of the temperature of the surroundings. Thermodynamic equilibrium versus other equilibrium. A system is said to be in thermodynamic equilibrium if it satisfies the three conditions of equilibrium: thermal equilibrium, mechanical equilibrium, and chemical equilibrium. But first I want to ask, what is equilibrium? Equilibrium is a state of balance or a balanced condition. Thermal equilibrium. There is no temperature difference within the system and between the system and surroundings. For example, if you put a hot coffee on the table with spoon, now if you leave them in the table for a few hours, they will attain thermal equilibrium with the temperature of the room, because there is no heat interaction between them. Mechanical equilibrium. Mechanical equilibrium, there is no unbalanced force within the system and between the system and surroundings. For example, if you have an object and you applied force 5 Newton force on the left side and on the right side is also 5 Newton force, the object will still remain on its place, because the mechanical equilibrium stated that there is no unbalanced force within the system and between the system and surroundings. Chemical equilibrium. Chemical equilibrium, there is no chemical reaction within the system and between the system and surroundings. For example, if you put iron rod with coating on the room temperature, and the room temperature consists of oxygen and moisture, the oxygen and moisture will create rust. If you put iron rod without coating, now if you put the coating, the iron rod will not create any rust because of the oxygen and moisture, because these elements will create chemical reaction. but the chemical equilibrium stated that no chemical reaction within the system and between the system and the surroundings. I am Erlefel Tamboboy. Thank you for watching. Please subscribe to my YouTube channel.